JavaScript is a programming language that people love to hate. A long time ago, developers used to pride themselves on being back-end developers because it was more challenging and complex. JavaScript was just a toy for annoying people on websites. But it's 2019, and today we have tools like the cloud, Docker, and many APIs that abstract away the complexity of back-end development. If you're starting up a company today, there's a good chance you'll do the majority of your development on the front end with JavaScript. So today I want to show you how to write good JavaScript with modern features. And so the first thing you need to know is how to debug your JavaScript like a pro. And the way we do that, of course, is by console logging stuff. And I'm saying that with a straight face. There are good ways to console log and bad ways. Let's imagine we have 3 different objects, each one assigned to its own variable. The obvious way to log these is just one after the other, but the main problem is we don't know the name of the variable when this gets logged. But there's a trick we can use here called computed property names, where we add the variables to an object. Not only does this reduce the code footprint, but it also tells us exactly which variable defined this data. One line of code, one console log, and all the information we need. But maybe this data is extra important, so we want to make it stand out with some custom CSS styling. You can substitute data and also CSS styles by using a % sign. So we'll add %c and then have the second argument be our actual CSS style. And now we get this bold orange color in the console. One thing you might have noticed is that the objects all share common properties, so maybe we could display those as a table. This is really useful when you have an array of objects. Just do console table with the array. I could probably do a whole video on console logging, so I'll just show you a couple more things here. If you're benchmarking performance, you can actually keep track of time in the console. We'll first define our timer and we'll give it a name of looper. Then we'll set up a while loop and we'll go through a million iterations in that loop. When that's done, we'll run console time end. As you can see here, it takes an average of about 4 to 5 milliseconds to loop a million times. Keeping track of time is great, but what if you need to know where a console log originated from? Let's imagine we have a really important function that deletes items from our database, and we want to make sure that we don't accidentally call this method twice. You can add a console trace to your function, and it will give you a stack trace for where it was called and what defined it. If we run this code, we'll get a console log that tells us the function was defined on line 35 and then called on lines 37 and 38. So now that you're a debugging expert, I'm going to show you a few different ways you can make your code as concise and efficient as possible. Let's imagine we have an object with some animal data and we need a function that will tell us how to feed the animal. This is just a function that returns a string, so inside that string we'll interpolate a few values from that object. This doesn't look too bad, but you'll notice that we're repeating the word animal over and over again. There's a technique called object destructuring that we can use to eliminate most of the repetition here. If we have a function that takes an object, but we only need to use a handful of its properties, we can destructure those in the argument itself. We just wrap it in brackets and then pass in the names of the object properties that we want to use. So now we can format the same string, but we never actually have to use the word animal directly. This might seem like a modest gain on this simple function, but when you have a big object with a lot of properties, this can make a huge difference. And I completely understand that some people don't like that bracket syntax in the object argument, so there's actually another way we can do this which is just as good. This time we pass in the animal object like we did originally, but then we set up a variable that has the names of the properties in that object set equal to the object. And now we can use those properties like variables throughout the function. And this tends to be the better way to go if you have multiple objects to destructure in a single function. The next thing we'll look at is template literals, which we've already been using in the code, but there's more to talk about here. When I first started programming about 10 years ago, jQuery was the cool thing in JavaScript, kind of like React is today. But unfortunately, it didn't have all of the awesome things that we have in JavaScript now. For example, you would see a lot of string concatenation that looks like this, where you have a variable plus a string, and you have to manage the spaces in between, plus an expression, plus a whole bunch of other stuff. This type of code is incredibly annoying to deal with, but template literals in modern JavaScript solve this problem completely. Instead of concatenating values together, we can actually interpolate them directly into the string. You can do this by defining your string with backticks, and then use $ brackets, and then whatever variable or expression you want inside of there. So we'll go ahead and grab the properties we need with object destructuring that we learned just a minute ago, and then we'll interpolate those into the string itself, which is a lot more readable and a lot easier to maintain. But you can actually take things a step further and build strings in a purely functional way. So we'll write a function here called horseAge that takes an array of strings as the first argument, and then can take whatever other arguments it wants after that. We can look at the arguments to this function and use them to compose a string. So here we're going to look at the age of the animal, and if it's older than 5, we'll say it's old, otherwise we'll say it's young. And the last thing we'll do is return the actual value of the string. That's a pretty standard looking function, but the interesting thing here is that instead of passing a regular argument to this function, we can actually just attach it to a template literal and it will parse the arguments in it. This might seem kind of weird at first, but instead of doing parentheses with the arguments, we'll just attach our template literal, and it will parse all of the string segments as an array of strings as the first argument to the function that we defined. Then it will handle all of the other arguments in the order in which they appear inside of the $sign brackets. In other words, you can take a single argument and use it to compose multiple values in the return string. This can be a very powerful concept for templating, and it's actually used in the Polymer project now via a library called lit.html. So now that we know how to work with strings, we're going to move on to the spread syntax to work with objects and arrays. Let's imagine we have one object for a Pokemon and the other one for the stats that define its various attributes. Let's say we want to assign the properties from the stats object to the Pikachu object. One way to do that is to just redefine them one by one on the original Pikachu object. For one, this is just really ugly and verbose, but we're also mutating the original object when we most likely want to create a new immutable object. Because let's say that our Pokemon levels up over time, we want to represent each level up as its own object. We could use object assign here and take the original object and merge it in with the stats, and this will merge them together from left to right. Or if we just wanted to update a single property, we could add an object with that property in it. This isn't too bad, but there's a more concise way to do this with the spread syntax. By creating a new object and placing our existing objects in it with 3 dots in front of them, it will compose a new object from left to right. So the properties farthest to the right will have the priority. Again, this is mostly just syntactic sugar, and it just makes your code more readable and easier to maintain. And it's also possible to use the spread syntax on arrays. So let's imagine we have an array of strings, and we need to push additional items to this array. The old school way to do this would be to just push new items to the array one by one, but in today's world we can reduce these 3 lines of code to just one by defining an array with the new items and then the spread syntax on the original array. If we add the 3 dots to the beginning, then it's the equivalent of doing an array push, because it will append the new items to the end of the array. But the nice thing is we could just add this to the end of the array, and then we have the equivalent of array shift. And we might even take the original values and just splice them in the middle of the array, giving us even more flexibility. And this code brings back some memories. You see this little trailing comma here? This used to be the kind of thing that would break an entire JavaScript program and be really difficult to figure out. But luckily in modern JavaScript, it just works, and it's actually kind of considered a good practice because you can reduce the number of lines that change when you do git commits. Now it's time to move on to loops. Let's imagine we have an array of numbers here that represent the order totals that we've had throughout the day in our app. Now let's say we need to compute some values based on this array, such as the order total, maybe we need to add some tax to each one, and filter out the high value orders to be reviewed by a manager. One option is to just use a classic for loop like you'll find in pretty much every programming language. We have an integer that starts at 0, while that integer is less than the order's length, we will increment it by 1. Personally, I hate loops that look like this, and I almost never use them in JavaScript. But while we're in the loop, we can start computing our values. For the total, we will just do plus equals with the order total. Then to create a new array with the tax added to it, we'll go ahead and take the order amount and multiply it by 1.1 to add 10% tax. Then if we have order values that are greater than 100, we'll go ahead and add those to the high value order array. This code is A, very ugly, and B, it's mutating values that might make our code a little more unpredictable. Luckily, we can reduce this down to just 3 lines of code by using modern JavaScript array methods. If we want to take an array and then have it accumulate to a value that equals, say, a total amount, we can use array reduce. It takes a callback function as the argument, where the first argument is the accumulated value, and the second argument is the current value in the loop. So if we want to sum up all of the items in the array, we can just do the accumulated values plus the current value, and when the loop finishes, that will give us the total of all elements in that array. Mapping and filtering values is even easier. If we want to add tax to all the items in the array, we can just take the values in the array, then map them to their value times 1.1. And lastly, we can use filter to create an array that only has the values greater than 100 in it. Whenever the callback function equals true, it's going to allow a value through. So in other words, if the value is greater than 100, it will allow that value through to the new array. I wanted to save the best for last, and that of course is async await. Let's create a method called random that returns a promise that resolves to a random number asynchronously. Now let's imagine that we want to retrieve 3 different asynchronous numbers, one after the other, and then add them all together at the end. That might seem like a silly example, but that's actually how things work a lot of times in the real world when you have to retrieve one item from the database, get some data, retrieve another item from an API, and so on. With promises, you wait for an asynchronous value to resolve, and then you handle it with a callback function inside of then. Once you have your data, you can return another promise, and then chain another then callback to it, and continue this pattern on for as long as you need to. You end up with this ridiculous looking code where you keep saying and then, and then, and then.
No and then. No and then. No and then. No and then.
But fortunately, there's a really nice solution to this, which is async await. Basically, it allows us to express asynchronous code in a synchronous format. We can come down here and rewrite our promise chain. The only difference is adding async in front of the function, which will force it to return a promise. But the real benefit here is that we can use await in front of our promises and have them resolve to an actual variable value. So instead of using those then callbacks, we can just say const first equals await random and do the same thing for the second and third number. And now it's much easier to read and understand this code because we can just go line by line and see that we're awaiting one number, awaiting another number, and so on. Async await is one of the most awesome things to ever happen to JavaScript, and it really deserves its own video. Right now we're out of time, but in the future I'll show you some of the cool things you can do with it, like use it in conditional statements or use it in for loops and things like that. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe, and make sure to check out the live stream next week to see if you won some free swag, and if you're serious about building apps, consider becoming a pro member at angularfirebase.com. You'll get all kinds of exclusive content designed to help you build and ship your app faster. Thanks for watching, and I'll talk to you soon.